So in first lecture of cryptography, we will just see the few concepts. Like basically, first of all, we will see the introduction to cryptography, and then these few indicative content points we will see. Like understand terminology and the historical evolution of cryptography. Okay, so we will see what is the historical value for cryptography, the basic terminology and the history of cryptography. Okay, and in that basically we will see some historical process, ciphers and cryptanalysis. Okay, so maybe you are not getting these terminologies. Later we will see in details, then you will understand what does this mean. Okay, so in ciphers we will see shift, substitutional and Wegener, Stream, and Lorentz. Okay, then we will see the concept of fusion and pseudo and number only and the perfect forward accuracy. Basically, the subject of, so let's see, these are the learning outcomes we will cover in today's lecture. Actually, we will try to cover, if not, then maybe in next lecture we will cover these. Understand the terminology and historical evolution of cryptography, and in that, in your assignment basically you will add these points. Explain the terminology in cryptography and describe the evolution of encryption methods. Okay, okay, so first of all we need to understand that what is cryptography. Basically you have seen in your WhatsApp messages, when you start chat with any person, on top of that you will see a notification, maybe a note written in every chat that this chat is encrypted. So what does mean by encryption? It's mean that we have just convert the message into some, like something else. We just represent the characters with some different characters and maybe different symbols. Like we will convert it into a different language. Okay, and then when a person send a text to another person, they will get that text, and they have to decrypt it again to understand that what the previous person have sent them. Okay, so then we have to decode that, decrypt that. Okay, so cryptography means that we are going to make our chat safe. We want to convert our chat into a safe message, and then we will communicate over the internet. Okay, so let's see the cryptography, the practice of secure the communication. So basic purpose behind cryptography is we want a secure communication over the internet. Okay, uses ciphers to hide the information. So we will later on see what does this term mean, like ciphers, what are the ciphers? While cryptanalysis is the study of breaking those ciphers. Okay. Early ciphers like Caesar and substitution ciphers were simple. Later, more complex methods like we will see these in upcoming slides. So first of all, you need to understand the concept of cryptography. Like one person is going to communicate with another person, and he or she wants to write something over the text. Okay. So normally we have our letters in this order, like A, B, C, D, and E. But when it comes to the cryptography, we will write a message. Like for example, we will write, now we will encrypt it with another language. Okay. So this is our simple letters we use in this way. But when we will crypt it, we will represent it with this. Like we will represent A with D, B with E, and C with F, and so on in this way. Okay. And at the last, when we will have X, Y, and Z, then we will represent them by A, B, and C. We just represent our message into another language. Okay. So we will represent the C with what? F. So we will write down F here. O will be represented by R. D is represented by G. And E will be represented by H. So this means we just done the cryptography here. Like we just try to use this cipher way. In cipher, we just see here two methods, Caesar and substitution. Now we are using in this way the substitution method. Like we are just alternating our letters, like we are alternating A with D, and we are going to modify B with E, and we are replaced C with F. So where we will use these letters, instead of these, we will use these. Okay. It means that we just convert our communication and convert our message into another language. If a third person in the way get our message, they will not able to understand it, because we have the key, which is this. Like we know that we have represent the A with D and B with E, C with F, and so on. The person who is getting our information in the middle of the way, they are not able to use that information. Okay. So in this way, our data will be safe. So this was the easiest method in ciphers, which is substitution method. But we have some other methods as well, like Caesar and substitution are the easiest way of ciphers and simplest ways. Then later on, we have discovered some more complex methods, but they are more like secure. Okay, they are complex, but they are more secure. Then we will may prefer to use these ciphers rather than using the Caesar and substitution method. Okay, so we have Wagenaar cipher and Supreme ciphers and Lorentz ciphers. Okay, emerged each with their own strengths and weaknesses in term of security. Okay, and the next terminology, obfuscation, while not strictly a cipher, it involves making information harder to understand without necessarily hiding it completely. Okay, so basically in this way, when we have used this cipher way, we completely hide our information to into another language. Okay, because we have used different alternative letters. But in it, we will just make it more complex to the other person to understand it. Okay, so sometimes we can use this as well. So basic purpose behind cryptography, you can easily see here, like the one person who is going to text another person, he have write a message here, and then when we are going to send it, it will send into another way, okay, into another code. Like we will decode it later on. So we just have this text, and when we send it over the internet, it will encrypt it, and we will convert it into a code like this. And later on, when it just reached at the specified location, like to the specific person for whom it belongs, so we will decrypt it using a secret key. What is the secret key? Like the secret key we have used to convert this message. Okay. Now here we will again use the same key to decrypt this information, and then the person will get the required information as it is, as the person have sent it. Okay. So what is the purpose of cryptography? Like if a person trying to access this information in the middleware somewhere, so they are not able to understand this code. Okay. So, right, we have to convert it in such a way that if somewhere our data breaches, so if any unauthorized person try to access this information, they are not able to access this because we just encrypted our information. Basic terminology and history of cryptography. So, cryptography means the practice of protecting information through different codes and through different ciphers. So we already have seen what does mean by ciphers. Like we can use the substitution method. We will just replace our letters with some other letters. Okay. And then we will convert our message into a encrypted form. And we can also use codes, like we can also use numbers. For example, let's say I'm using A and I want to replace A with 1. And for example, with B is going to replaced by 2 and C is going to replaced by 3. So if I just send this 1, 2, 3 to someone, and in middleware, my data is going to breach somewhere. So the person will not understand that this is A, B, and C. Okay. So we can use the codes as well. Like you can write down your whole letters and then you can convert it to different numbers and different symbols as well. You can use different symbols. For example, I want to replace A with at the rate. Okay. So wherever I will use A, I will replace it with at the rate. So this is the way we can encrypt our information to protect it from the unauthorized access. Cryptanalysis is basically the study of breaking and analyzing the cryptographic systems. Like how we are using different terminologies, different methodologies, different techniques when we want to crypt our information. Okay. So the study regarding those systems, those techniques, those methodologies are known as the cryptanalysis. Okay. Early use in the ancient civilization like Egypt, Greece, and Rome for military and diplomatic communication. So in history, basically, the term of cryptography is also have seen because in ancient civilizations like Egypt and Greece and Roman, military use this diplomatic information so that if any person get that information, they are not able to understand it. When that message, particular message will be reached at the required location, they have the keys as well So they will convert the information with the help of keys, and then they will see what the message are going to convey to their military. Okay. So some basic terminologies like cryptography, already we have seen the science of writing the secret code, and we can say the information we are going to convert into another words, into another language, maybe hiding the information. So basically the process of hiding the information is known as cryptography, as we just alternate our whole text into something else. Okay, so we just hide our information. Cipher, a specific algorithm used to encrypt and decrypt. So cipher means we are using a specific terminology, specific technique, specific algorithm, specific methodology to encrypt our information and decrypt our information. And what does mean by encryption and decryption? The process of converting the plain text into the ciphertext. Now, what does mean by ciphertext? Ciphertext means that when we just apply any algorithm, when we just use any cipher technique to convert our data, now that data is known as the cipher data. For example, A, B, and C, we are going to replace this with C, D, and E. Okay, so this one is the plain text, and this is now what? Ciphertext. Okay. Also, you can say that plain text means a readable form of information, and ciphertext means unreadable form and unreadable code. Okay. Decryption means the process of reconverting the ciphertext into the plain text. Like we just have to convert the ciphertext back into the plain text. Plain text like the original and the readable form, ciphertext the encrypted message. Cryptanalysis, again, cryptanalysis means the science of breaking and analyzing the ciphers to recover the original plain text. And maybe you can say the cryptanalysis is about the study of and is about the science of different algorithms, different techniques, different ciphers we are going to use to encrypt and decrypt our data. Okay, and then we have seen a term of obfuscation, act of making something unclear and obscure or unintelligible, often used to obscure code or data. So it again means that we are going to make something unclear. It is not able to read by someone else. So we just trying to make secure our information somehow. These are the terminologies we will see again and again. So some historic ciphers and cryptanalysis. So let's see these terms as well. Shift cipher, substitution cipher, and Vigenère cipher, Satrine cipher, and the Lorentz cipher. So these are the five, we will see them. So shift cipher, also known as the Caesar cipher. Each letter is shifted by a fixed number. Okay. So shifted cipher means we are just replacing our alphabets with the different numbers. Okay, like we can replace A with 1, replace B with 2. Okay, so that's how it will work. Substitution cipher means that each letter is replaced with the another letter. Okay, according to a fixed mapping. Fixed. Mapping means that we just convert A with the D, and the next alphabet like B will be replaced with the next alphabet, then the D. Like we can't use another alphabet here. We will just use the same order, but we will just differentiate with one or two letters at the start. Okay. And then the left letters, like at the end, if X and Y are left, F, Y, and Z, we can replace it again with A, B, and C. Cryptanalysis and historic sum ciphers, like we have seen what is shift cipher and what is substitution cipher. Okay. Likewise, we can use some other ciphers for encrypting our information, but they are more complex than these. Okay. Like in shift cipher, we just need to replace every letter with the fixed number. And in substitution cipher, we just need to replace the letters with some other letters with a fixed mapping, right? But now we have to see some complex cipher methods like Wagoner cipher. And in Wagoner cipher, we can use the polyalphabetic substitution using a keyword to vary shifts. Now, what does mean by this? For example, we are going to represent the A with D, and maybe we can also use the D for K. Like by replacing the K, we are also using the D. Like we have polyalphabetic system now. Okay. So what we do in this, we will use the same method like substitution, but in substitution we have a fixed mapping. Like for each word, for each alphabet, for each letter, we have some different letters against them. Like for A, we can say D, and then for B, we can say E, and for C, you can say F. So we are having a mapping against each letter. But in Vaginary cipher, we are not having the same technique, a little bit different, which is like poly alphabets. Like we can use the same alphabet for replacing different letters. Okay, so this is about Vaginary cipher. Why this is complex than the substitution method? Because in substitution we have to decrypt according to a mapping, okay, which is fixed mapping. But when it comes to Vaginary, we don't know. Either we have to put the, like in the replacement of D, either we have to put the A, or we have to use the K letter, okay? Because we have used the same letter for replacing two letters, maybe three letters. Let's say for M, we also are using the D. So now in this way, we are using the same letter for many letters for replacement of the many letters basically. So that's why it is a little bit complex. Then it comes to the string cipher, encrypts one bit or a byte at a time, typically using a pseudo random key string. Okay, so this is can be used in coding, like we can encrypt one bit or maybe byte. Like one bit means 0 and 1. And when it comes to the byte, byte means 8 bits. Okay. And Lorentz cipher, German cipher machine used during WLL, broken by British cipher analyst at the Bletchley Park. Okay, so this is also a cipher technique, but this is also a complex one. But when it comes to the security and the protection of our data, these techniques are more secure and more powerful. But at the same time, they are difficult to use by a simple person who don't have much information of the computing and regarding these techniques. So let's see them again. Caesar cipher, a substitution cipher where the each letter is shifted by a fixed number of the position. Drawn the alphabets, for example, a shift of 3, and so on. Okay. Substitution cipher, a more general form of the encryption where each letter is replaced with a different unique letter or symbol. Like we can represent the A with @, okay, and B with 1, let's say, and C with, for example, double quotes, okay. And for D, we can use the backslash. And for E, we are going to replace the E with, you can say, the equal to sign, okay. And then for F, we can use 1, okay. So we can replace a different unique letter, symbol, or a number maybe. But when it comes to the Caesar cipher, we will use the shift system. Like if we are using the 3 shift, it means that A becomes D, B becomes E. Like we will represent them with the difference of 3 alphabets. Okay. And for X, we will represent X by the A, and Y with B, and Z with C. Okay. So that's how Caesar cipher works, and substitution cipher work with a different way. In Caesar cipher, we can use different letters, different symbols. But in Caesar cipher, we just have to follow a order of letters with different shift numbers. If we are using the shift of 2, it means that A are going to replaced by the C and B is going to replaced by the D. Okay, because now what we have done, A, B, and C, we have shifted with 2 letters. Okay, so A will be represented by C, and when it comes to the B, B will be replaced by the D. Okay, and if we want to replace the C, then it will be replaced by the E. Okay, the remaining and 2 letters will be replaced, like the Y and Z will be replaced by A and B. Okay, so that's how we will convert using these ciphers. Wagnerian cipher, again a polyalphabetic substitution cipher that uses a keyword to shift letters, making it more complex than the simple substitution ciphers. Now, what we are doing, we are using many alphabets substitution cipher that uses a keyword to shift different letters and making it more complex than the simple substitution. Like we can say the A can be replaced with @ and we can also replace A with D, and we can also replace A with by M. Okay, like one word is going to replaced by many words, or maybe we can use two or maybe three or maybe four words in Wagnerian cipher. Okay, stream cipher, a cipher that encrypts the plain text bit by bit and byte by byte. Bit by bit means the 0 1 concept. We can replace 1 and 0. Okay, and for byte by byte means we will replace, for example, we have 8 letters and up to so on. So we can represent the 0 1 0 1 and 0 1 and up to so on. Okay. Key stream generated by a pseudo random number generator. Okay. Lorentz cipher, a complex German cipher used during the World War II, known for its use for a router machine. It was one of the most sophisticated cipher at that time. Okay. So you just need to understand that we have different sort of techniques when we want to protect our data, when we want to use any secure method to convert our data into another form. Okay. Historical evolution, ancient times, every evidence of the cryptography appears around 1900 BC with the used in Egyptian tomb, classical era, the Caesar cipher and the other simple substitution ciphers were used. In medieval period, polyalphabetic ciphers like Wagnerian cipher emerged, and then in 19th to 20th century, mechanical and electrical cipher machines like the Enigma and the Lorentz machines were developed, leading to the more complex ciphers. And in modern area, the cryptography relies heavily on the mathematical theories and computational power. Modern ciphers are designed to computationally infeasible to break. Okay, so they are more complex and they are going to protect the data in a better way. So obfuscation is also a technique which will be used to make the code and information intentionally difficult to understand. Okay, so we will not change our information, but rather we will try to make it more complex to understand by a third party. Okay, often used to protect the intellectual property and prevent the reverse engineering. Like we can't decrypt this information because we just try to make it more difficult to understand by someone else. Commonly used in the malware to hide the malicious activities from the analysis tools. Okay, so we can use it in the malware as well. Obfuscation is not encryption, it aims to make the code and data harder to understand. Now, encryption means that we are going to convert our message into another language. But obfuscation means we are not hiding our information, we are not converting our information, but we are just trying to make it difficult to understand by a third part. Okay, and that's all. But not necessarily unreadable. It may be readable by someone, but they are not able to understand it in actual. Okay. Techniques include the renaming variables, reformatting code, and adding irrelevant code. Okay, so we may use these techniques like we can rename the variables, we can reformat the code, and we can add some irrelevant code in the required code. Obfuscation used to protect the intellectual property or to make the reverse engineering more difficult. Like reverse engineering means that no one can try to decode that information. Okay. Obfuscation is an umbrella term for the variety of processes that transform the data into the another form in order to protect the sensitive information or the personal data. Three of the most common techniques we can use in obfuscate data are encryption, tokenization, and data masking. So all of these are going to make the information unreadable by a third person. Like not unreadable but difficult to read. Like in obfuscation, basically we will just do the modifications a little bit, and in the ciphers we will just rewrite the whole information into a different form. Okay. Pseudo random number generation, algorithms that generate the sequence of numbers that appear randomly. Okay, and used to create the cryptography keys and initialization vectors. So basically pseudo random number is going to use to create the cryptographic keys and initialization vectors. Deterministic in nature, like some seed produces the same sequence. Okay, change our letters into different random numbers, and then again we will change it, and then at the time when our information reach to a required location and just received by that device, then it will again change into the previous information. Nonce number only used once, a unique value used only once in the cryptographic protocols, prevent replay the attacks by ensuring the freshness of each transaction. Okay, and commonly we can use it in authentication and encryption schemes. Like for example, in our WhatsApp and in our different applications, we have the technique of double authentication. So what does mean by double authentication? That we will get a code to our number, and then we will authenticate that we are going to use this application. So the double authentication process is relevant to this. Like we have different numbers here, and we are going to detect them by different other numbers. Perfect forward secrecy. It ensures that the compromise of long-term keys does not compromise past session keys. And it also protects the confidentiality of past communications implemented in the secure communication protocols such as TLS.